Hi, my name is Orn Mendonça, and I am a part of the What Next Robotics team, which takes part in the first Tech Challenge. And today, I'm going to give you a basic introduction to engineering and robotics. So that brings us to the question, what is engineering? The term engineering comes from the Latin word ingenium, which means a natural capacity or something along the lines of invention. Engineers find solutions to problems or ways to make improvements to the processes that we do in our daily lives. The simple goal for engineers is to make life easier for everyone through the use of mathematics and science. So there are a couple of different engineering fields. There's engineering, aerospace engineering, mechanical engineering, chemical engineering, and a couple more, including robotics, as you can see here. But there's one thing that they all share in common. They all require science and mathematics. Engineering is a STEM field, which STEM stands for science, technology, engineering, and mathematics. So the basic idea behind engineering is turning your ideas into designs that actually come to real life, like things that you will physically be able to use most of the times. Um, so engineering requires thinking outside of the box to come to solutions. Sometimes the most standard approach isn't going to cut it. You need to be able to sit down and think of creative solutions to solve your problems. And so there's a whole process that most engineers follow that leads them to their solution and helps them plan out everything. It's called the engineering process. The engineering process is 6 steps, but during the process you can go back to the previous section because sometimes you need to jump the cycle in order to optimize your results to make sure that your final product is as good as it can be. So the first step in the engineering process is to state your problem. You're starting at point A and you need to get to point B. So point B is the solution to your problem. Once you state your problem, you need to be able to solve the problem. So once you know your problem, you can solve it. And in order to solve it, you need to be able to generate ideas, which is step 2. You need to brainstorm ideas and creative solutions to solve this problem. So after you brainstorm ideas, you can find ways and look and break down the solution and see if it's the most effective way to solve your problem. And step 3 is to pick a solution. You pick the solution that looks like it's the most effective. And so after you pick the solution, you build a prototype of it. Here in robotics, after we go through these 3 steps, we build an actual prototype. So we make a robot with actual wheels and actual metal parts, as you can see here. We can actually test it and see how it does. So step 4 is to actually build a prototype. And so if you're building a prototype, it can be made of anything from cardboard to Legos to even real metal in robotics. What you do next is you evaluate the performance of your prototype. Did it do as well as I hoped it would? And you give yourself a little mental grade. It's like, did my prototype solve my problem? And if not, you ask yourself why. So step 5 is evaluate, and you evaluate your prototype. And step 6 is present your results. So you make graphs, charts, data tables to see what went wrong. So after you draw out everything and write out everything, make a bunch of graphs, you can see how your prototype performed and actually understand what might have gone wrong, or if it did well, why it did well. And so having graphs as a reference is always very helpful. So when you present the results, you can see everything. And in case there's something wrong, you can go back after seeing that there's a certain problem in a certain area. You can go back into another step of the cycle. And that's the best part of the cycle. It never ends. Congratulations, you just used a real engineering process, one that real engineers use all the time when they make decisions in their respective fields. This process is very vital to having your creation work to the best of its ability, and it's very dynamic, so you can always go back and forth and go through it again to make sure that your solution is the best that it can be. And thanks for watching. If you want to contact us, you can contact us at info@whatnext.org. If you want to schedule something like a Skype session to learn more about robotics, or you can also visit our website at www.whatnext.org. And once again, thank you for watching.